Welcome to Showcase Night 1 of 3. My name is Robin. I'm one of the founders of the program, along with Dave, who's another founder of the program. Thank you guys for coming, first of all. I'm going to take a minute and just give you guys some background on Bluestamp Engineering, the program itself, and we'll get right into the presentations. So Bluestamp was created 5 years ago, right here in New York. So we started with a very small pilot program of 10 students. The program has now grown to 5 cities, about 140 students this year. So it's a really nice increase in the number of students who want to just come and learn about engineering, build some projects, get frustrated along the way, and then find ways to really succeed through a lot of painful and challenging milestones that they had to achieve. So, what you see the students presenting tonight is just really an amazing compilation of just incredible perseverance to do something they've never tried before, but actually make a working project. So, it's something short of amazing. A lot of the projects that we do are really college-level projects, but at the high school level. So it's a really nice entree to get them excited about engineering, but also basically go to colleges and say, here's what I've done when I was 16 or 17 years old before anybody else. So in the program, I just want to briefly introduce the staff who's made our lives really easy this summer. So thank you guys for that. I'd also like you guys to just say a few words about yourselves, what school you go to, and maybe the coolest project you've made so far. Okay, so Sandy first.
Hi everyone, my name is Sandy. I go to NYU and NYU Poly for physics and mechanical engineering. And the coolest project that I've done so far is probably an autonomous underwater robot vehicle that is required to pick up things and navigate. Yeah.
Lucian?
My name is Lucian. I am a master's student at Columbia University of Electrical Engineering. And I think the coolest project I did was use neural networks to do traffic control.
Hi, my name is Stephanie. I'm going to be a rising junior at Cornell, and I study computer science. And I think the coolest project I've done was a music composer, where I wrote a program and it'll generate music every time you run it.
Kevin?
Hi, I'm Kevin. I go to NYU Poly. I'm doing my bachelor's in electrical and a minor in mechanical engineering. The coolest project I worked on was the NASA Lunar Bias competition, where we built a robot that would essentially mine the moon or Mars.
Hi, my name is Randy. I go to Rice University in Houston. I study electrical engineering as well. The coolest project I've worked on is probably a research lab at Rice where they do multi-robotic systems, where they have robots that interact with each other, and you basically program them as a whole as opposed to programming them individually to complete a task and have them do stuff as a team, as a unit.
Oh, and every year we hire back one exemplary student from previous years, basically serve as a TA as well. So it's a hard position to get. It only goes to really the people we feel perform the best. So that's Liam this year, who's a student last year. So just want to talk about where you're going to school, what you go last year.
So in the fall, I'm going to be attending Vanderbilt for engineering, probably electrical, not sure yet. And last year I built a robot, sort of like Robot Spire. I took apart its microcontroller, put in an Arduino microcontroller. At first I just got to sort of follow a line, but then I wrote some Python code which allowed me to sort of control over the computer in various ways.
All right, Sandy will be the MC tonight, and she'll take it away.
Hi everyone. I already gave my little intro. So to kick off the program, tonight we have Patrick, whose project is the omnidirectional robot. So let's give him a hand.
My name is Patrick. I actually graduated. I'm not going to high school anymore. But I will be a rising freshman at Lafayette College next fall. Now, before I get to my main project, I'm just going to talk about my starter project. It was the Minty Boost. Essentially what this does is provide the 5 volts to charge my phone. My phone is really bad, but I upgraded so I really don't need it anymore. let me come down to that. 2 batteries supply the 3 volts needed, and there's a boost converter chip inside that ups the voltage to 5 volts, that what is needed for any phone to recharge. That was kind of simple. Now, let me show you a little bit about my omnidirectional work. Where's the audio?
Should be plugged in.
Let's go.
Pause it. Pause the video. There's a dial.
That was up there.
So the left controls forward, backwards, and to the left and right. So, and then the right one is like quick turning. It's strictly like it stays in place when you're left and right.
All right, that was a video when it was actually operational. Today, while trying to add a GoPro, so I was going to do a live stream through a GoPro, just watch it from my phone exactly, so I wouldn't have to be watching where it goes. So I finally got that all working, going together, and I was gonna go solder the pieces together, and 2 of my wheels stopped working. I built this from scratch, so I'll show you what one wheel can do. It's not really an omnidirectional robot, but it's a shame. It would have been really cool to actually could have moved in a circle. It goes really fast. So my idea for this was, well, I couldn't exactly follow a schematic. There was no clear thing, start, no shape, no nothing. You just give me the engine, sparks, build. Okay. So I decided on a triangular shape, mostly because I decided that too many cuts would be too difficult to do. And wheels mount, and everyone else used wood, and I decided to use acrylic, mostly because this is the only clear one you see. It's kind of cool. So. Now, the thing I take away most from my experience at Blue Snap is, well, I'm going into Lafayette College as an engineer major, undeclared. But I was going to mechanical at first, but my work here, my frustrating work here, it's made me move towards electrical engineering, because I really want to continue building things like this. Like, come on, like PlayStation 2 controller. I grew up on this, so that was pretty cool. So we'll be going into mechanical engineering at Lafayette College. Thank you.
Questions?
Oh yeah, questions. I'm sorry.
What are you gonna try to do to fix those wheels?
Okay. So before my 2 motor controllers died, only one was not working. So now we ordered like pieces. It's coming tomorrow. Tomorrow I have to really hurry up and work on it to see if it was that problem. And once I get that hooked up, once I know if the wheels are good, I can actually hook up the GoPro and get the live stream. Tomorrow I'll be done. Probably add a few more mods. Take out a little bit of the acrylic because it's a bit too heavy still. And put some safeguards so nothing gets short circuited. Any more questions? Okay. Thank you.
So that's pretty awesome that he is still like so adamant about doing engineering despite facing all these difficulties, right? Like, bravo. So up next we have Jacinta with her LED bracelet.
Hi, my name is Jacinta. I'm a rising sophomore at Fox Academy. And my starter project was also Unity Boost. I'm always on my phone. It's always dying. So when I saw that I had an option of making a portable charger, I my main project was the LED bracelet. Honestly, I have no idea why I picked it. I just thought it'd be really cool. I watched the video and went for that. Okay, so yeah, my Minty Boost has a pretty bad short right now, so I can't really plug that in. But yeah, my main project, the LED bracelet, I 3D printed it. I modeled it. I created it using 3D modeling software. That was definitely difficult, getting the dimensions to work out. Didn't completely work out, but it's there. It's lit with a LED strand that I'm powering with a trinket that I coded using Arduino. Arduino is the software that I downloaded onto my computer that turn lines of code into actions for electronics. So yeah, one of the wires in the LED strand, called the data line, takes the signal from the trinket, from the code, to basically tell the strand what to do, while the positive and negative wires sends power. Thank you. Sends the power to light it up. It's powered with this very tiny but powerful battery. It's 3.7 volts. Originally, I could not get the strand to light up with this battery, but the strand was actually 144 LED lights long, so that was definitely not enough power, because I had to look that up to realize that. After cutting it and finally getting it to work, I was probably the happiest person alive. Well, yeah. The main problem I had would probably be coding. I coded for almost a week, when the problem the whole time was that I didn't download the drivers that I needed for the code to actually work. So after getting that down and actually getting my code, yes, it was working. This week I soldered on an accelerometer to create a sensor. Well, basically to create a sensor so the bracelet could catch movement and interact with the environment. But I didn't code that yet, so right now it's not going to actually work. I plan on doing that this week. Yeah. So basically, being in this program for the past 6 weeks was actually pretty interesting. It definitely told me that you cannot ask for all the answers, as Kevin so kindly taught me every day. Every day I ask him a question, and he's like, Google it. I don't know, you tell me. But yeah, I actually really had fun with this program. Originally I came here not knowing anything about engineering, or honestly scared that I was going to be the only one to not finish anything. But it worked out. I had a really good time. So.
Did you have fun?
Yeah, I had fun. Sometimes.
Can you tell us more about the 3D printing process?
Oh, the 3D printing process. Well, I printed it using SketchUp. Originally when I looked at it, I had no idea what I was doing. I thought that I was going to be on that forever. It looked so difficult. But Sandy actually helped me understand how to work it. And I printed out a piece way too big the first time. The bracelet would have probably been like a scoopy. And I had to finally get in the dimensions right. I got a pretty good size. The printer was kind of acting up for a while, so I didn't get the bracelet when I wanted, but eventually I got it.
Would you consider?
Oh yeah, that's another thing that I was gonna work on this week, because that's not very stylish. Having that just out there, so I plan on taking that again.
You mentioned two things. One is an accelerometer and an LED. Could you talk about what those are?
Well, LED stands for light emitting diode. And an accelerometer, I'm going to be honest with you, I have no idea. But I will make sure I look that up by the end of the day.
I could have sworn you explained it to me like 3 hours ago.
I did. Well, I knew earlier. They didn't come to me.
Okay.
Alright. Thank you.
I personally think that one of the coolest things about the Synthesis project is how it combines a lot of the engineering disciplines. And so each of the staff members, as you can probably tell, we have different sort of focuses and specialties. And she was talking to like every single one of us. There were some problems with her bracelet that I didn't know how to solve, so she would have to talk to Kevin or Stephanie. And yeah, I think that hopefully you really liked learning about all those things. And so up next we have Fatou Mata with her MP3 player.
So hi guys, my name is Fatou Mata, and I am a rising sophomore at Promise Academy 1 High School. So here is my starter project, the USB multi-boost charger. But right now it doesn't work, but it do convert the 3 volts into 5 volts with the battery, but I think I have a shortage or I have to add electric tape. And here's my MP3 player that doesn't look like an MP3 player. So I'm using buttons to control commands. So I can play the next song and play the previous song and stop it. So at first it was kind of difficult because I had to find the coding and wasn't following directions properly. But I then got the hang of it. But adding the buttons was the most difficult part. I had to get a new code, the button player tool, that was in the previous code, but in examples. So after that, I then had to include the buttons and define the variables and add the pins. So the next play and stop was already included, so that was a good start. But I then had to add the volumes, the next, and no, not the next, the previous in the coding. So the volumes, if I press the high volume, most of the time it will stop because it will exceed to the negatives because 0 is actually the highest and 100 is the lowest. So I had to change that with if statements and also modify with the next and the previous. So after I got that working, I then wired it up to the breadboard with jumper pins that connected the analog pins to the breadboard. So after that, I then tested it out and really was mad excited, so excited. And now it works, but I have to get a box and drill it, add buttons to the box, and solder this because it won't stay in the breadboard for long. But in Bluestamp, my experience started off difficult because I didn't know anything. Like soldering was easy and fun, but the soldering for the multi-boost was And I soldered in the parts wrong and had to desolder and solder. So that took like a week. But for the MP3 player, I had to do a lot of coding and I didn't know how to write codes. But with the help of Sandy and Jonathan, which is not there, and Randy, and all the instructors, I finally got it and now it works.
Question. I couldn't tell when you were playing it. Were you playing it from your computer, or was that your system totally separate from the computer?
No, the computer just powers it.
Okay.
Yeah, so I need to add batteries too.
Isn't it awesome that Clashmada has created something that we so take for granted every day? And I mean, like MP3 players, we all, I assume, listen to them or like have listened to them, but she's built one from scratch, so I think that's really awesome. This is a little different. We're going to show you guys a student named Amon who's not with us today, but he has worked on a Raspberry Pi touchscreen camera, and we're just going to show the video for you.
Sandy, if you could start at 1 minute in. About. That's good.
So now I'm the camera. This is the cameraman. This is me. So whenever I take a picture, say this guy, you just tap it, and it takes a picture. Go over here to the settings. You can do a group partition. You can sync it to your Dropbox. There's also a photos folder. Done. You can change the size, change the effect. You just tap it into. But artists like that during the project where sometimes you got downloaded the wrong operating system, so I had to re-download a different operating system that works with a touchscreen. I did that about 3 times. Each time it took like an hour to reformat and rewrite every operating system once the SD card. Also, the network adapter wasn't working, so I had to keep re-downloading a driver for the network adapter, so I can download the other softwares for the camera. The camera also wasn't working when I took it out for the first time, so I also had to get a new camera, and then it started working. I started to change from B to B+, so I had to re-download the operating system again.
So same deal with Amon, you know, he's built for himself this camera, which is something that we always see everywhere, but yeah, he's done it all by himself. So we're just going to take a quick intermission right now, if you guys would like. There's a lot of food outside. We have some chips and guac and drinks. You guys can all take some and...
I go to Promise Academy, and this program was recommended by my guidance counselor. So I actually took the opportunity, and my starter project is a voice changer. It doesn't work, but it was cool when it worked. It allows you to change your voice to a high pitch, a low pitch, a robot voice, and a vibrating voice. So, this is my LED necktie. It's not working properly, but still working. So, my necktie consists of a microphone, 15 neopixels, and a floorboard, which is Arduino compatible. microcontroller. When I was talking to the microphone, a signal was transferred to the floorboard, which tells the NeoPixels how to lay out. A problem that I had with this was the connection between the NeoPixel and the floorboard. I connected it with conductive thread, so it was hard trying to secure it around each NeoPixel. But yeah, as you can see, it's still a problem, so I'm going to use that. Something I learned from this. Well, I learned that engineering is something I don't want to do. But it was still a good experience, and I'm glad I did it. I'm pretty happy with it. Any questions?
What made you pick the LED necktie to do it?
Honestly, I just chose because I just like the lights. So it was cool. It drew my attention. And I don't know, it was something different. Oh, and I added lace to my tie. Any other questions?
Would you actually wear that?
No. Maybe on like wacky tacky day for school or something, but yeah. Is that it?
So why don't you want to do engineering? Because the aesthetics of your tie are not pleasing to you?
I don't know. Coding just really threw me off. Engineering. Yeah, so that's pretty much why. Is that it?
Did you have any friends that like helped you while you were having
No,
like
I didn't. Is that it?
Why did you choose the color black for your tie?
My color, that was nice looking, I guess. I didn't want to choose blue. Is that it?
One more question.
If you're not going to wear it, can I have it?
Sure.
I have one more question.
Yeah.
Why did you lie when I just asked you that?
I went over it. Okay?
Okay.
Okay, that's it, guys.
So one of the goals of this program is to have all of you guys walk away having learned something. I guess even if in this case that you don't like engineering, which is fun. But I hope, Danielle, that you continue to dabble in whatever interests you from now on. And so up next we have Ruby, who has also left the program, but I'll be showing her video as well.
Is that it?
Hi, my name is Ruby and I'm a rising junior at the Hewitt School, and this is my final metal detector. I made some modifications to obviously the way it looks, but if you want to see the specific details of my circuit, you can go into my last video, but I'm just going to give you a little bit of how my circuit works. So the main part of my search coil, my circuit is my search coil. So my search coil detects when metal is near because this has a magnetic field, but the metal also has a magnetic field. So when those magnetic fields increase, the current also increases. So the current goes through the search coil, and because there is larger current, the transistor can sense that there's a larger current, and the buzzer beeps really quickly, indicating that there's metal near it. I also made some modifications. As you can see, my search coil is different. I'm using magnet wire rather than hookup wire because I found that and change the sensitivity of the code to make it less sensitive. The sensitivity number lower, but it will still be more sensitive because of the amount of wire that I have. I also changed my power source to a 9-volt battery because it was portable rather than plugging my Arduino into USB. And I also made my circuit onto a solderable breadboard rather than just regular. So I've mounted my metal detector already. and I'm gonna try to find a piece of metal that's under this paper. So. If you think it's quicker when it's up here, so yeah, I'll take it out. And there's metal here.
Any questions for Ruby?
Yeah, no, Ruby really, what's interesting about her is that she was only a 4-week student, I think? 3-week student, so she managed to build out on her own in such a restricted time frame, which I think is pretty cool. So up next we're going to have Casimir demonstrate this project, but they'll need a couple minutes to set up.
Okay. I'm Casimir. I'm a rising senior at Dr. Michael Croft Senior High School in Miami, Florida. I actually chose this program because one of my sister's friends had heard about it, and she told my sister about it, and she told me to check it out. And I just looked at the website, and I became pretty interested in all the options you had and everything you could build. I chose my starter and, well, let me start with this. So my starter project, which I built in about a day, is that it's an array of LEDs which lights up when in response to sound. So I have to change sensitivity. But once I stop talking, it stops lighting up. So whenever it hears something, it lights it up. It works by when the sound goes into the microphone, a little magnet vibrates within coils of copper. And it's a property called electromagnetic induction, which the magnet produces a current in the copper, which is an electric signal, and it goes into the circuit. The circuit goes to the IC chip, one of the pins on it, and the IC chip, it like changes that circuit to a series of them, and sends it through resistors, which delays the circuit and makes it into a series of clock pulses, which are basically like electric pulses in a beat. So like that. And that is sent through this IC chip, which then changes the course of the circuit to one of the LEDs around here. So I chose that one because I play music and I play guitar and I listen to a lot of music, so I figured it would be cool to just have something that lights up whenever I play or listen to music or anything. Alright, so for my main project, I built a computer that will go into my car in Miami. I don't have it here with me, unfortunately. But it's a computer which is like very small and compact and portable. It's like what Amon built was a Raspberry Pi camera. This is a Raspberry Pi as well. And first of all, I made a case which holds the driver board for the screen. And the driver board basically translates the stuff that comes from the Raspberry Pi into like signals and code that's relatable to the screen so you can display it. I built a case for it so that I don't have like circuit boards and everything hanging around in my car while I'm driving. What I programmed onto it was an MP3 player, or a media center actually, which plays videos, plays music, and displays pictures. And I can demonstrate the music right now. I'm using the mouse and keyboard right now because this specific part of it, it doesn't fit my touchscreen exactly, so I can't use it touch. But it'll be like on this screen while I'm driving, and I'll have like a smaller mouse and keyboard that I can use like safely, so I don't crash and see, it plays music pretty much perfectly and pretty good quality. The other stuff I programmed into it, it can be found on this port hub here. I'll just go step by step. These are the mouse and keyboard, so that's simple. This is a GPS antenna, which I had to program a bunch of installation, a bunch of applications and everything to read its data. And I can't demonstrate it in here because we're inside, so it won't get a good reading. But look at this one. When I'm outside and driving around, it displays longitude, latitude, altitude, and speed in like numerical data, so it's not useful basically because I have Google Maps. Why would I do that? This is a Bluetooth adapter, and what this will do is, what this will do is it connects to another Bluetooth adapter, which connects to an OBD port in my car, and what that is, it sends car diagnostics through that port, and that port is mostly used by mechanics. When they repair your car, they will connect their computers to that port so they can see intake, manifold intake temperature, speed, RPMs, everything like that. But I'm going to use it so I can see everything, and I'm going to be able to see if my car needs to be maintained, if it needs to be repaired, or anything like that. And once I get home, I had to program a little bit more to add more applications to read all that data. And the other stuff I added were games, which is basically just stuff like Snake, Tetris. That's not really for me to play because then I would crash, but it's more for like my passengers if they feel like playing a game or anything. I chose this project mainly because I'm more like mechanically inclined, so building the case and the stand, which I don't have with me right now, but those were fun for me. But programming, it was not fun. I hated it. But I like cars a lot, so I liked the ability to see all of my like car statistics and everything. What this program has shown me, like I said, I don't like programming, so I'm definitely not going to be a computer scientist or engineer or electrical engineer. Definitely going to be a mechanical engineer. It also provided me with a lot of connections because I met and talked to a lot of the lecturers that came, a lot of the guest speakers that came, and one of them was a mechanical engineer, so that was a good connection for me. I also learned a lot about power tools and different materials. Like this case here is made of acrylic, and I had never worked with acrylic before, and it's actually a very like versatile material that I can use. Besides that, any questions?
Just out of curiosity, what's like intake, manifold intake?
Oh, intake is the air that goes through the engine because the gas can't combust without like oxygen. So the engine needs to take in air, and that's what it takes. So like if you see intake temperature too high, that might mean that your engine is overheating because the air coming in is like being heated up. Oh, RPMs is rotations per minute, and that's something we use.
In your future as a mechanical engineer, what big time project do you want to work on? Say 10 years from now.
Plane.
A really fast plane.
Yeah. Oh, cars. Cars. I would love to work on cars. Actually. Alright.
So that's everybody we have for this evening. We'd like to thank you all for coming by and seeing the presentations from all of our students. Before we let you go, I always like to tell parents two things. First is this program is what it is today because parents like you pull us aside and say, hey, that was awesome, never change this about the program, or hey, this is an issue, maybe think of another solution to this problem you had. We change it every year. Every year we get stronger, better, faster, bigger. So please feel free anytime to reach out to us. Even if you think something might come up, you can give us a ring and we're happy to chat. The second thing is, I'm sure a lot of your students haven't told you this, but they all have their own websites. We've been videotaping them all night. We take a lot of video, we do a lot of documentation. So if you want, you can go to our YouTube channel or our Flickr channel. The Flickr channel, the photos are up here, so there's a lot of shots. You can download them all of your kid and have them or send them around or do whatever you like. And you can go to their webpage, see all their documentation, and send that link around. So as far as their webpage, finding that, you just have to go to bootcampengineering.com and search their first name in the little search bar, and they'll come right up. So don't let them tell you that there's no video, no documentation whatsoever. It's all up and it's all available for you. We'd be happy for you to spend time on the site and click around and be proud of your son or daughter. So with that, I'll invite you all to finish up the cheese and wine and crackers, and thank you for coming.
Not